so get out the note taker I just gave you, and then also you need your blue sheet. We're going to finish up the 3 on the back of our blue sheet today. All right, so we have some other stuff going on in these circles. So we're going to talk about them. They're called special segments in circles. Okay, so if you look at the top, what kind of lines are those? They're secants, but they're also chords, right? Because a chord goes from one end to the other. So if you want to find a missing piece of this segment, here's what happens. You have to take AB and you multiply it by BC. So whatever this is times this is going to equal this times this. So as long as you remember what to do, it's not really that difficult, okay? So if you look at number 1, I have 2 chords that are crossing each other inside this circle. They're inside, all of it. So this times this is going to equal this times this. So what is this segment right here? X times what? Equals 12 times 9. Now don't add these together. They're bounded by multiplication. So 8x equals 12 times 9. And then divide by 8. So x is equal to 13 and a half. Yeah? What, Robin? Okay, so let's look at number 2. We have to take this, which is what? X. It doesn't matter which one you start with, okay, as long as you stay on the lines. So X, I'm going to write it down here, X, I'm going to open parentheses. Here's why. We have to multiply it by this, which is what? X plus 10. So you have X times X plus 10 equals both of these multiplied together. So I'm going to put X plus 4 times X plus 2. Now, this is just an algebra problem from here. Setting it up is the geometry algebra from here. So what do I have? What's it called right here? What do I do? Distributed property. So this becomes X times X, which is X squared, plus X times 10, which is 10X, equals, do you remember FOIL? You have to FOIL this side. First, outer, inner, last. So first times first is outside times outside. Inside times inside. And then last times last. Okay, this looks terrible, but I promise you it's going to get better in just a second. So I'm going to bring this down. X squared plus 10x equals x squared. Now look, guys. Can't you add these two together? What's 2 plus 4? Why can I add them together? Because they have an x and an x. X and x. I'm sorry, Misty, I'm on your way. X times x is different than x squared. Okay? Bring down your 8. Now, what do we have the same exact thing on both sides? What do you see? An x squared and an x squared. So if I subtract this x squared from both sides, what happens? They cancel. So we're going to be left with 10x equals 6x plus 8. Well, how do I get the 6 to the other side? Subtract. So 10 minus 6 is 4. And then bring down your 8. And x is equal to 2. That's as hard as it will get. That right there is as hard as this will get. Can we go ahead and write what's happening on our blue sheet?
Yes.
Okay, so what's happening is we have 2 chords intersecting in the circle. So you can just write 2 chords intersecting. tell me what letters I can, what segments, like tell me what the letters are that I can multiply together. So like what's the first segment you want to start with? Okay, so AB times what? Equals. Good. Yeah, write that down. Okay, will you go try 3 for me? Take a few minutes, try 3 and 4 the same exact way. Check your answers on the board. Okay, so remember when you're foiling, this becomes x squared plus 8x plus 4x plus 32. I canceled my x squareds out right here. So then I combined and got 12, and I subtracted to get 8, and then divided to get 4. When you're done, go ahead and flip to the back. Okay, so our next scenario is we have 2 secants, right? Okay, so this gets a tad bit more confusing, but not terribly. So what happens here is you're going to multiply the outside times the whole line. Oops. You're going to do the outside times the whole line equals the other outside times the other whole line. And what I mean by that is, so on this line, AC, we're going to multiply AB times AC. And then AD times AE. Y'all got that? So let's look at 5. Ignore this line. We're looking at EI. What is the outside portion? So we're going to multiply 8 times. Now what does that whole line consist of? 8 and x. So we have to do 8 times 8 plus x. Equals, what's the outside of the second line? 10 times, what's the whole thing? 10 plus 24. I'm going to write 10 plus 24. If you want to condense that already, that's fine. So from here, can I distribute this 8? What's 8 times 8? So you're going to have 64 plus 8x equals, now, if you condense this, that does become 34. So you really have 10 times 34, which is 340. So what do I do now? Subtract 64, which gives you 276. Thank you. And then 276 divided by 8. What's that give you? Can you try number 6 whenever you're finished? Okay. Did you get to this point? Okay, now I have some bad news for you. Those x squareds are not canceling out, right? Which means I'm going to have to, subtract the 36 over here and set it equal to 0. What does that look like? Easy method, right? Oh my goodness. Do you think that your math teachers make you learn things incognitally for a reason? Okay, so I need two numbers that multiply to give us 36 but add to give us 9. Multiply to give us negative 36 and add to give us 9. 12 and 3. Which one of those is going to be negative? The 3. Because it has to add to make a positive number. So watch this. You're going to have x plus 12, x minus 3 equals 0. Okay, but notice how they're still set equal to 0. We haven't solved it yet. So here's how you completely solve this one. Matt, are you with us? Okay, so if you break these two apart, and we set x plus 12 equal to 0, and x minus 3 equal to 0, this actually becomes x what? X equals negative 12, and x equals positive 3. Because I set it equal to 0. So if you get x by itself, you subtract 12. If you set this x minus 3 equal to 0, you add 3. But look, let's be real. If x is a segment of a line, is it going to be negative 12 or positive 3? Positive. A line can't be negative when others around it are positive. So this answer is not valid. Your answer is x equals 3. There won't be a whole lot of those. Okay, we have one last scenario. Lesson 8, I know that 1, 3, 5, and 7 run together. It's just a bunch of circles with a bunch of different things going on. Lesson 8 is like completely different, and it's the easiest lesson of the whole chapter in my opinion. So, if we get this, Friday, lesson 8 is going to be easier, and that's our last lesson of the whole year. Y'all excited? Y'all look scared. Your last test of the whole year is when? Tuesday. Okay, it's not. All right, so the last scenario we have going on is right here. So you have one tangent and one secant line. So notice this tangent line is not going through the circle. So what you do, whatever is the outside one, that's the tangent. And because it's not going to the inside of the circle, you just have to square it. So your formula is going to be JK squared equals the outside times the whole thing. So just switching it up a little bit. Matt, put your head up. JK squared equals the outside times the whole thing. So if you look at number 7, which one are we going to square? What number? 6. So your formula is 6 squared equals 4 times 4 plus x. It's okay.
16 plus.
What's 6 squared? 36. And then if you distribute, you get 4 times 4 is plus. Next. Subtract 16. Get 20. Subtract 16. And then x is equal to 5. Good. Try number 8.
That's right, because there's never eggs.
What is 3.3 squared? What's 2.2 times 2.2? What's 10.89 minus 4.84? What's your final answer? 2.75? Okay, let's go write on our blue sheet when you get done. Alright, so what's happening here? What two lines do we have? Two secant lines. So your formula, in this one, let's write, just as a reference, outside times whole equals outside times whole. Okay? Now, when we actually have these letters, what can we write? AB times AC equals AD times AE, right? Okay, and then our very last one, we have one tangent and one secant. This is the one where you're going to have something squared equals something times something. So let's write outside right here, and I'm going to write whole right here. So in this case, which one would be the one we square? Not JKN, that's the one you square. What's their outside? JL times JN. Alright, and I did give you a maze that I want us to go ahead and start. Now, here's how I want this to work, because I want it to be kind of particular. So, do you see how I've labeled the maze numbers? You are not going to use all of these. However, I want you to show me your work on a separate sheet of paper. Separate sheet of paper. You don't have to do all of them. You only have to do the ones that lead you to the answer. So, this is how it should start. On your separate sheet of paper, I want to see number 1. So go ahead and get out a separate sheet of paper. Share with your neighbors if they don't have any. We don't use paper often in here. Suck up to them real quick. Put your name on it. Alright, so number 1. What should my equation look like? Is this the first, second, or third scenario we did? This is the first one. They're both chords on the inside. So what should I do? Yeah? 9 equals 3 times. Okay. Good. Show me your equation on a separate sheet of paper. Okay? If we don't finish this today, we will finish this tomorrow. Okay? Hey, real quick, let's get all of our